problem solving session, I am going to solve problems with light damping, and in both the problems I am going to be concerned with Q factor or the quality factor that is defined for a lightly damped harmonic oscillator. So, problem number 1, show that in a lightly damped system with high quality factor Q, the maximum of oscillations is advanced by a phase phi equals 1 over 2q. So, let me just remind you what happens if there is a system which is undamped, it goes on with equal amplitude. On the other hand, if there is a system which is damped, its amplitude starts going down with time. And what we want to show is that this maximum is advanced. Advanced means it occurs earlier by a phase phi, all right, is equal to 0. And therefore, I have minus gamma by 2 cosine of omega t minus omega sine of omega t. So, this is going to be e raised to minus gamma by 2 t is equal to 0, and this gives you tangent of omega t is equal to minus gamma over 2 omega. So, the maximum occurs when tangent of omega t is equal to minus gamma over 2 omega, which by definition of q I can write as minus 1 over 2 q, where q is omega over gamma. And this immediately tells you that omega t is going to be equal to 2 pi minus 1 over 2 q. In writing this, I have made the approximation that gamma over 2 omega is much less than 1, and therefore, tan omega t can be written as omega t. So, you can see that this whole thing, otherwise the maximum would have occurred at 0, 2 pi, 3 pi, 4 pi and so on. Now, this maximum has advanced by a factor 1 over 2 q. So, these maxima for damped oscillator occur at 2 pi minus 1 over 2 q, or the phase has advanced by 1 over 2 q. In the second problem, we have a person of mass 45 kilograms sitting on a swing 5 meters long. He maintains an amplitude of 2 meters while swinging. And how does it do it? By pushing the ground while passing the equilibrium position, moving backwards. If quality factor of the swing is 50, how much impulse does the person impart during pushing? So, let us see, this is a problem you are all very familiar with. Here is a person sitting here and he is going back and forth, and what he does is, as this swing comes back here, he pushes the ground and pushes himself back, then comes back one round, pushes again. So, during one round he is pushing the ground with some impulse and therefore taking some energy. How do we go about solving this problem? So, in the swing, if the impulse imparted is J is going to be F, let us say it is done for a very short time delta t, then the energy is going to be equal to F delta t times V equilibrium, that is J times V equilibrium. This is easy to see because F times V is power. So, F V delta t becomes the energy. So, this much energy he takes in, and this should be equal to energy lost per cycle. Now, energy lost is given by the quality factor. So, quality factor Q is energy stored divided by energy lost per radian. So, energy lost per cycle is going to be 2 pi times delta E per radian, which is going to be E over Q, where E is the energy of the system. So, I am going to have J V equilibrium, that is V equilibrium is the speed when he passes through the equilibrium, is going to be the energy stored divided by Q. So, all I need to find is E, V equilibrium, and I am done. So, let us see now, for the swing, omega is equal to, the angular frequency is going to be equal to G over L square root. I am taking G to be 10, so it is 10 over 5, which is equal to square root of 2 or times 2 pi, there is a 2 pi here also, times 2 pi. And V equilibrium is going to be omega times the amplitude, which is going to be 2 root 2. Energy is going to be 1/2 m V equilibrium square, but that is the total energy, the kinetic energy while the swing is passing through the equilibrium point. So, I have J V equilibrium is equal to 2 pi times E, which is 1/2 m V equilibrium divided by Q square. Now, I am going to cancel this V equilibrium with the square point here. So, J comes out to be, this 2 cancels, pi m V equilibrium divided by 50, which is 3.14 times 45 times V equilibrium, which is 2 root 2 divided by 50. And you calculate this, and this will come out to be roughly 8 newtons second. So, that is the impulse that the person imparts to maintain this amplitude of 2 2 meters.